Okay, so this property, this electron affinity does not show a regular trend and it is increasing from left to right in a period. From lithium to neon, it is increasing with some deviations. சின்ன deviations ஓட leftல இருந்து right போகும்போது the value of electronegativity increasing, and the reason for this increasing value is due to the increased nuclear charge. When we compare these two things, if we compare lithium and beryllium, compared to lithium, beryllium has higher nuclear charge, and compared to beryllium, boron has higher nuclear charge. So we can say when we move from left to right, the nuclear charge increases. Nuclear charge increases in the sense its attractive force towards electrons increases, so that electron affinity also increases. So that is given in the third point. Due to the increased nuclear charge and decreased size of atoms, what is increasing? The electron affinity increasing from left to right in a period. Okay, and there are certain deviations. A few elements will possess almost zero value of electron affinity. சில elementsக்கு electron affinity value will be zero. So ஏன் அப்படின்னு பார்த்தோம் அப்படின்னா, already we have seen about the electronic configuration of atoms. If an atom possesses either completely filled or half filled electronic configuration, it will be considered as a stable atom. ஒரு ஆட்டத்துக்கு அதனுடைய electronic configuration வந்து completely filled ஆவோ அல்லது half filled ஆவோ இருந்தா, so that is called as stable atom, and those stable atoms are reluctant either for adding electron or for losing electron. So இந்த ஆட்டம்ஸ்க்கெல்லாம் stable electronic configuration இருக்குதோ, அது ஈஸியா எலக்ட்ரானை வாங்கவும் செய்யாது, எலக்ட்ரானை கொடுக்கவும் செய்யாது. So we can say such kind of elements, the elements with completely filled or half filled electronic configuration will possess almost zero value of electron affinity. So அந்த மாதிரி elementsக்கு electron affinity எப்படி இருக்கும்? Zero value இருக்கும். Okay, now here there is a plot given. In the y-axis we have taken electron affinity or energy released, whereas in the x-axis we have taken the elements, these elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. And the atomic numbers I have written. Lithium's atomic number is 3, then beryllium's atomic number is 4, then 5, 6, 7, 8, 9 and 10. So here nuclear charge increases. So lithium is the left side element. Periodic table left la இருக்குது. So it will possess lower amount of electron affinity. அதனுடைய electron affinity கம்மியா இருக்கும், ஏன்னா அதனுடைய nuclear charge கம்மி. Since it possesses lesser nuclear charge, its electron affinity also will be lesser. ஓகேவா? பட் நம்ம பார்த்தோம் generally increases. அப்ப லித்தியத்தை விட பெரிலியத்துக்கு higher electron affinity தான் இருக்கணும், but it is showing lower electron affinity than lithium. Why? இது ஏன் இப்படி கம்மியான வேல்யூவை காட்டுது? இங்க பாருங்க, I have written the electronic configurations of lithium and beryllium. ஓகேவா? Lithium's atomic number is 3. Its electronic configuration will be 1s2, 2s1. Then beryllium's atomic number is 4. Its electronic configuration is 1s2, 2s2. Okay, so here lithium has no completely filled configuration, whereas beryllium has completely filled configuration. 1s orbital is also completely filled and 2s orbital is also completely filled. So because of this completely filled electronic configuration, this element possesses lesser electron affinity than the lithium. Okay, so next element is boron. Compared to beryllium, boron's nuclear charge is high, so its electron affinity is also high. Then carbon. Compared to boron, carbon's nuclear charge is high, so it shows higher attraction towards electron, hence its electron affinity is high. Then come to the case of nitrogen. If carbon atomic number 6, nitrogen atomic number 7. So we can say nitrogen has higher nuclear charge. இதை விட இதுக்கு nuclear charge அதிகமா இருக்குது. Nuclear charge அதிகமா இருந்தா attractive force அதிகமா இருக்கணும். Attractive force அதிகமா இருந்தா electron affinityயும் அதிகமா இருக்கணும். But it is exceptional case. Why? அப்படின்னு பார்த்தோம்னா, nitrogen's atomic number is 7 and its electronic configuration will be 1s2, 2s2, 2p3. This is the orbital diagram I have drawn here. For 1s orbital, 2 electrons. So 1, 2. Then 2s orbital, 2 electrons. 1, 2. Then 2p orbital, it has 3 electrons. 1, 2, 3. And this is called as half filled electronic configuration. ஒவ்வொரு subshellலையும் ஒரு single electron இருந்துச்சுன்னா that is called as half filled electronic configuration. And you know that when an atom possesses either half filled or completely filled electronic configuration, it will be considered as a stable one. So nitrogen is a stable, so it shows poor electron affinity towards the extra electron. Adanalada carbon vida nitrogen has lesser electron affinity even though it has higher nuclear charge. The nuclear charge higher irundhalum due to the half filled electronic configuration it shows lesser electron affinity, which means it shows poor attraction towards the electron. Then come to oxygen. Okay, then come to oxygen atom. Compared to nitrogen, oxygen's nuclear charge is greater. It has the atomic number 8. Nitrogen has the atomic number 7. So compared to nitrogen, oxygen has higher nuclear charge, and due to this higher nuclear charge, its electron affinity will be high. Okay, then come to fluorine. Dear students, fluorine is one amongst halogens. Halogens na idalam fluorine, chlorine, bromine and iodine. Okay, generally in the periodic table all these halogens will show higher electron affinity. Yeah, abdin pathona they have the outer electronic configuration 2,7. That is 7 abdinittu irukum. So last shell 8 electrons are there means that will be the completely filled configuration, and that atom will be regarded as a stable one. Okay, so since it has 7 in the valence shell, it is in need of 1 electron. In the mari atoms ku or electron theva, so they will be greedy towards electron and these will possess higher electron affinity. Okay, one word la kekalam, the atoms with higher electron affinity is dash abin kodutanga, those are halogens. Okay, then come to neon. Neon is a noble gas. Neon, what is the atomic number of neon? 10, and its electronic configuration will be 1s2, 2s2, 2p6. Okay, so here 1s orbital is completely filled, 2s orbital is completely filled, then 2p orbital is also completely filled. So there is no possibility of adding any electron. Electron add panna mudiyadu, we cannot extract any electron. Electron loss pannavum vaikka mudiyadu. So these elements, that is noble gases, helium, neon, argon, krypton, xenon and radon, so these elements will possess 0 electron affinity. Why? In the sense because of this completely filled electronic configuration. So completely filled electronic configuration irukradanaala there is no possibility for either removing an electron or for adding an electron. So we can say all the noble gases possess 0 electron affinity due to the completely filled electronic configuration. Okay, mama. So in a period we have seen that it is not varying in a systematic way, but generally it is increases. So this we have seen in this concept. Okay, mama. So with this the variation in a period is over. Then we have the variation in a group. So that we will see in the next one. Okay, okay, so variation in a group, variation of electron affinity in a group. Okay, okay, so in the case of period, the variation of electron affinity in a period, we have seen that from left to right it is increasing, but from top to bottom, மேல இருந்து கீழ வரும்போது this value electron affinity is generally decreasing. அதாவது மேல உள்ள எலிமெண்ட்ஸ்க்கு அதிகமான எலக்ட்ரான் அஃபினிட்டியும் கீழ உள்ள எலிமெண்ட்டுக்கு கம்மியான எலக்ட்ரான் அஃபினிட்டியும் இருக்கும். So we can say the electron affinity generally decreases from top to bottom. Okay, okay. Any reason பார்த்தோம் அப்படின்னா there are two factors are responsible for this decreasing electron affinity. Those are, the first one is increased atomic size. About atomic radii we have already seen. From top to bottom, if we measure the radii of atoms, it show a regular trend of increasing. மேல உள்ள எலிமெண்ட் சின்னதா இருக்கும், then பெருசாகி பெருசாகி கீழே உள்ளது ரொம்ப பெருசா இருக்கும். So this is the trend in atomic radii. Okay, so when the atomic radii increases, the number of inner shells increases. Dear students, here they have taken halogens, fluorine, chlorine, bromine, iodine and astatine. Okay, so imagine if we took the last element, that is astatine, it will have a tiny nucleus at the center and it will be surrounded by a number of inner shells. நிறைய shells இருக்கும். இப்போ இங்க பாத்தீங்கன்னா ஒரே ஒரு shell தான் இருக்கும், இங்க ரெண்டு shell இருக்கும், இங்க மூணு shell, அப்படி number of shells increasing. Okay, number shells na the vattapathaigal. So when the number of shells increases, what is increasing? Shielding effect increasing. Shielding effect na enna? In the nucleus கொடுக்கிற attractive force வெளியில போக விடாம the electrons present in the inner shell உள்ள electrons will screen or shield. So nucleus கொடுக்கிற attractive force வெளியில போக விடாம the electrons present in the inner shells either screen or shield. So that is called as shielding effect. Here shielding effect will be less. ஏன்னா ஒரே ஒரு ஷெல் தான் இருக்கும், அதனால shielding effect will be less, but here shielding effect will be more. அதனால the nucleus force exerted by this nucleus cannot be able to pull this extra electron inwards. So adanala what is decreasing? The electron affinity decreasing from top to bottom. Puriyadama? Number of shells increase agiradanaala shielding effect increase agudhu. Shielding effect increase agiradanaala the atom doesn't show proper affinity towards the extra electron. Adanala da the electron affinity value generally decreases from top to bottom. Puriyada? Okay, so here they have taken fluorine, chlorine, bromine, iodine and astatine. So fluorine has the actually fluorine the higher irukano. First fluorine irukano, then chlorine, then bromine, then iodine, then astatine. This is the order. But here there is a case. When we compare fluorine and chlorine, let us write the electronic configuration. Fluorine's atomic number is 9, whereas chlorine's atomic number is 17. The electronic configuration will be 1s2, 2s2, 2p5. This is the electronic configuration of fluorine. Then chlorine எடுத்துட்டோம் அப்படின்னா 1s2, 2s2, 2p6, then 3s2, 3p5. This is the electronic configuration of chlorine. Okay mama? Okay. So imagine this is fluorine. இது நம்ம fluorine எடுத்துட்டோம் அப்படின்னா what about the size? It is so compact. ரொம்ப சின்னதா இருக்குது. So இன்னொரு புதுசா ஒரு எலக்ட்ரானை நம்ம இன்சர்ட் பண்ணும்போது it results electron repulsion. அங்க ஆல்ரெடி அது காம்பாக்டா இருக்கிறதுனால புதுசா ஒரு எலக்ட்ரானை கொடுக்கும்போது it results electron repulsion. So to avoid that electron repulsion, this fluorine possesses lesser electron affinity. புரியுதாமா? fluorine ஆல்ரெடி ரொம்ப சின்ன சைஸா இருக்குது. அதுல இன்னொரு எலக்ட்ரானை கொண்டு இன்ட்ரோடியூஸ் பண்ணும்போது it may result electron repulsion. So அதனால it shows poor electron affinity than chlorine. But chlorine பார்க்கும்போது அதை விட கொஞ்சம் பெருசு. So here what can be avoided? The electron repulsion can be avoided. Okay va? Then chlorine, then bromine அதோட கம்மியா இருக்குது. Iodine has lesser electron affinity than bromine. Then astatine has lesser electron affinity than iodine. Okay, so it is decreasing only this exceptional. The reason for this exceptional case I have told you, due to the electron repulsion. Fluorine ரொம்ப small size இருக்கிறதுனால the addition of extra electron may cause electron repulsion, so it possesses lesser electron affinity. Okay mama? With this the concept of electron affinity over. What are things we have seen? The first one, definition of electron affinity. So what is electron affinity? The energy released when a neutral atom gains an electron, as a result of which what is obtained? An anion will be obtained. That is the definition for electron affinity. The amount of energy released when an electron is added to a neutral atom. So it is represented like this. M plus electron gives M minus plus energy. As a result of this process, an anion is obtained and the energy released can be measured in the unit kilojoule per mole. Okay va? Okay. Then next we have seen that the variation in a period. The variation of electron affinity in a period. So it is, the variation is not a systematic way. Generally it is increasing from left to right, and this plot we have seen. The reason for everything we have seen already. The next variation in a group we have seen. Okay, so in a group the electron affinity value generally decreasing. It is due to what? Increased atomic size and shielding effect, and this plot we have seen. Okay mama? Okay, so with this what is over? Electron affinity is over, and I have a few questions for you to check your level of understanding. Okay ma? Okay, how many questions are there? There are 3 questions I have taken. The first question is, noble gases have 0 electron affinity. Why? Okay, what is the question I have given? Noble gases have 0 electron affinity. Why? Then second question is, electron affinities of beryllium, magnesium and nitrogen are almost 0. Why? This is the second question we are going to discuss. The next one, the electron affinity of chlorine is greater than that of fluorine. Why? So in this plot I have explained that. So these are the three questions we are going to discuss. Now let us see the first question. Noble gases have zero electron affinity. Why? Already I have told you the answers. Noble gases. Do you know what are noble gases? Yes. The molecules with completely filled electronic configurations are called as noble gases. Okay, so since they possess completely filled configuration, they doesn't show any affinity towards electrons, so that they possess zero electron affinity. Let us see the answers now. The first question, noble gases have zero electron affinity. Why? So the answer is given here. Since the noble gases have completely filled electronic configuration, their general electronic configuration is ns2 np6. So because of this completely filled electronic configuration, they show zero electron affinity. Okay. Then second question, the electron affinities of beryllium, nitrogen and magnesium are almost zero. Why? So beryllium's atomic number is 4. Its electronic configuration is 1s2, 2s2. So we can say it has completely filled electronic configuration. Then when we study about nitrogen, its atomic number is 7 and the electronic configuration is 1s2, 2s2, 2p3 and it is a half filled electronic configuration. Then magnesium, its atomic number is 12 and the electronic configuration is 1s2, 2s2, 2p6, 3s2. So all the orbitals are completely filled. So these atoms, since these atoms possess half filled and completely filled configuration, they possess almost zero electron affinity. Okay, well, then third question, the electron affinity of chlorine is greater than that of which one? The fluorine. Why? Okay, the simple answer is it's due to electron-electron repulsion. Okay, in fluorine atom, the addition of electrons takes place in 2p orbital. The 2p orbital, first nucleus, then 1s, then 2s, then 2p. So 2p orbital is very close to nucleus. 1s, 2s and 2p. 2p is very close to nucleus. So addition of extra electron causes electron-electron repulsion. So it has poor electron affinity than that of the chlorine atom. Okay, mama? Okay, so with this the concept electron affinity over. Okay, dear students, it is very important concept. So watch the video twice or thrice to get a better understanding. Thank you.